Alright guys, welcome to the problem section of impulse and momentum theorem. So these are going to be on your test. I would say that you probably are going to have 3 of them. So they will look exactly like this, except for it's not going to be a picture like this. You're going to actually have to be able to pick out the information. But that should be no problem for you, because I would say, you know, an object that has a mass of 50 kilograms being pushed with 200 newtons of force at an initial velocity of 10 meters per second in 5 seconds. So all you have to do is pick out these. I'm not going to try to trick you. It's going to look just like this. You just won't have a picture. It will be a word problem, okay? So let's go ahead and get started. Don't forget your test Friday, May 15th at 11 a.m. So be sure that you are really familiar with these. I'm only going to do one, because the one that I do, again, is going to look identical to the ones that will be on your test, just different numbers. So you got to be sure you know how to do it, but, you know, let me know if you have any questions, okay? And let me know before, like, Thursday super late or Friday morning. I mean, I'll take questions anytime, but I don't want anybody to be freaking out on those days because they don't understand this. These really are kind of fun, I think, because it's really just solving for puzzle pieces, okay? So I'm going to go ahead and get started. So we know, based on our slide that we talked about in our impulse intro, which if you haven't watched those videos, you need to, we know that impulse is equal to a change in momentum. Another way we can write, it's also known as force times change in time. Another way we can write this with our impulse momentum theory is we know that impulse is exactly equivalent, so it equals the exact same as our change in momentum. Okay, so let's go ahead and write this out. So force, so F times change of time. Remember, change is written with that arrow, with the triangle, I mean. Mass is equal to change in velocity, or mass times change in velocity is equal to our change of momentum. Remember, momentum just equals P equals M times velocity. Our change, so this would be like our final velocity. Our change in momentum is going to be mass times change in velocity, okay? All right, so impulse equals our change in momentum, or mass times change in velocity. So all we've done is expanded those formulas. Got it? All right, so let's go ahead. Let's solve. We can solve for all of these things, and you need to be able to know how to solve for impulse, how to solve for change of momentum, how to solve for your final momentum, and how to solve for your final velocity. It sounds really difficult, but it's actually really easy, okay? So let's start. First things first, we can figure out our impulse right off the bat, right? Because our impulse is equal to force, so let me write, this is equal to impulse, and this is equal to our change in velocity, okay? So it's just a different way of writing it out. I just want to be sure that that's clear, because this can seem kind of complicated. It seems harder than it really is. So, force times our change in time, so we already have this information. What is our force? It's 200, right? 200 newtons. Times our change in time, which is 5 seconds. So that is going to equal to what? It's going to equal to 1,000. So we already know that our impulse is equal to 1,000. Now, technically, the easiest way to solve for this problem is if we know our impulse is equal to 1,000, then we already know our change in momentum is equal to what? 1,000, right? So we know that these two things have to equal each other because of the impulse momentum theorem. But we still have to work with this problem and this part of the problem and figure it out, because we have a change of velocity happening, and we want to be able to figure out our final velocity, because we have to figure out our final velocity in order to find our final momentum. Okay, so let's go ahead and figure that out. So we already know our mass. Our mass is equal to 50 kilograms, right? So this is equal to 1,000. Let's just write that out. So our mass is equal to 50 kilograms, and then we have our change in velocity. How do we write change in velocity? Well, a change in something is going to be its final value minus its initial value, right? So this would equal our final velocity minus our initial velocity. That's what change in velocity equals, okay? We already have our initial velocity told to us, right, in the problem. Our initial velocity is equal to 10 meters per second. So our final velocity, we don't have, but we're about to find, minus our initial, so minus 10. All right, so now we just go ahead and solve for this problem, just like we're solving for x. So if you imagine final velocity is written as x instead, if that helps you, then go ahead and do that. So really this could be x minus 10 if that helps you. All right, so 1,000 is equal to 50 times our final velocity, so it will be 50 VF, minus, what is 50 times 10? 500. So in order to solve for our final velocity, we need to get our final velocity by itself, right? So that would require us to add, sorry, I am wrangling a child right now. Add 500 on both sides, right? Because we want it over here. So now we would have 1,500 equals 50 VF. And in order to get our final velocity by itself, we would have to do what with this 50 on both sides? We would have to divide it. So 1,500 divided by 50 is going to be 30. So our final velocity is equal to 30. All right, but remember, that's what our final velocity equals. That's not what our change in velocity equals. What would our change in velocity equal? Change in velocity is going to be equal to our final velocity minus our initial. So we've just found our final. So it's going to be equal to 30 minus how much? 10, right? Because we got that in the beginning of the problem. So our change in velocity is going to equal 20. All right, so if that's the case, now we can figure out whether or not we solved for this, right? Because we already know our impulse equals 1,000. And we know that this is supposed to equal 1,000 too, because our impulse momentum theorem says that our impulse is equal to the change of momentum, right? So if that's the case, then it should be that our mass times our change in velocity, which is 20, change in velocity, that should equal 1,000, right? Because these need to equal each other. Well, it just so happens that 20 times 50 equals 1,000, right? So we know our impulse is 1,000, and we know our change in momentum is 1,000. Because we just checked it with our final velocity minus our initial velocity equals 20 times the mass, which is 50, is equal to 1,000. So we know our final velocity is equal to 30 as well, which we will need our final velocity when we calculate our final momentum. So let's go ahead and figure that out. So our final momentum, this is just our regular momentum problem. So really you could write it out as final momentum is equal to mass times our final velocity. And all we would do for that is we would do, I'm trying to keep her entertained by moving the marker, is 50, so our mass times our final velocity, which we just found, which is 30. So our final momentum is going to equal 50 times 30, which is going to be 1,500. All right, guys, again, if you have any issues with that, please let me know. But just know I'm not going to throw you a curveball. I'm not going to all of a sudden have you try to figure out a problem that we haven't already gone through. So your problems will look exactly like this, just different numbers on your test. So please let me know if any of this doesn't make any sense. Then, yeah, feel free to text me. And be sure that you do it sooner rather than later because I want all of y'all to be able to finish strong. I also will be posting a test review video for you guys tomorrow, which is Tuesday. All right? Say bye, Ireland. Say it is nap time. Not for me.